Can you guys hear me? Hello, anyone? Am I audible to everyone? Can you please reply in the chat?
Yes, sir.
Okay. What about Piyush and Binu? Other two guys?
Yes, sir, you're audible.
Oh, okay, okay, yeah. So if you don't want to speak, then you can reply in the chat, and if you want to speak, then yeah, it's good for me as well and for you as well.
So can you speak a little louder because your voice is coming very little.
Now can you hear?
Yes, sir. Now it's fine.
Okay, okay, fine. So today I gonna discuss the questions from week two and week two lectures. And first, I'm gonna be going through the topics a little bit so that you can have an understanding uh, how to solve those questions, and then I'll be solving some questions that will be helpful to solve those assignments. Okay. So so the first
Sir, I have a quick question.
yeah, sure, sure, tell me.
So I wanted to ask that if we register for the exam, then the exam will be written. And another question that I have is that the type of question that will be asked in the exam, will it they be the same type of questions that we're doing in the assignments or a little different?
So as far I know is that the questions gonna be CBT, right? It's like computer based tests, and most of the questions will be, I think, MCQ type, right? Because you don't have that much time to write theoretically, and like it is also difficult for people to check your answers, right? So it is much convenient to conduct MCQ based questions. So if you have any doubts, probably you can contact the NPTEL team. I'm not sure what they're gonna do. Okay, I think that will be much more convenient for everyone.
Thank you,
But
sir.
but my intuition is that it is gonna be MCQ based. Okay, so uh, uh, so we'll start with upper bounds and lower bounds of a set. So whatever I'm gonna talk about right now will be an ordered set. So I think you guys have maybe gone through the lectures for week two, because this class is a bit early since I had some problems, so that's why I have to conduct this class earlier than the next Sunday. So an ordered set is actually a set which is ordered. So this is a very basic definition, so it might look silly, but it's like ordered means given in two elements, you can compare them. Okay, so like if I give you x and y, then you can compare like x less equals to y, or y uh, less equals to x, something like that. And another property is that if three elements are given to you, x, y, and z, then you can compare if I say that x less than y and y less than z, then you can say that x less than z. So this two properties, if it holds for every element on the set x, then that set is called an ordered set. So a prime example of an ordered set is the set of real numbers. Okay, and because given any two real number, you can compare those real numbers, like if it is greater than the others or the less than the others, like that. And if you take any subset of real numbers, then that also follows that ordered set properties, because it's just inherently get all those properties from R, right? Specifically the ordered properties. And if you want to ask me for an example which is not an ordered set, and of course this is gonna be a set of complex numbers, right? Because uh, the set of complex number is like, let's say if there is a two element like 1 plus I and 2 plus I, then you do not, or you cannot compare these two elements, right? Because there are no orders. Because until you compute the magnitude, you do not have any ordered between two elements in complex numbers. So that's why the set of complex numbers are not an ordered field. Okay, so let me start with upper and lower bounds. So yeah, so yeah. So upper bounds and lower bounds. So mostly I'm gonna be talking in the set of real numbers. So if I take a set, presumably it is a subset of real numbers. Okay, so let a subset of R. Okay, then a number U is an upper bound of A if A is less equals to U for each A in A. So I hope you guys know this property, right? So that means every elements on the set A should be less equals to that given element or that given upper bound. It should not cross that element. So it's like if this is your set, then if this is your set A, then it should not cross this element U. Okay, so every elements are should always lie on the left side, correct? So this is called an upper bound. And similarly an element L is called a lower bound of A if B is greater or equals to L for all P in A. Okay, so lower bound means so something here. So let's say it is L, then every element should be lying on the right side of that particular lower bound. So that means if L is a lower bound, all the elements in the set A should be greater or equals to that element L. Okay, now this greater or equals to is possible because we are working in an ordered set, correct? Because R is an ordered set, we just have described. So that's why we can talk about less equals to or greater equals to. Okay, so that's why this is the definition of lower bounds and upper bounds. And another definitions that was given in the week 2 lectures are greatest lower bounds and least upper bounds. Okay, so I'm gonna also write the definitions of LUB or GLB. So this is the shortest form of greatest lower bound and least upper bound. And after that we'll be solving some questions from this topic, and then we'll see how to solve questions from this upper bound and lower bounds. Okay, so so an element let's say, so what should I call, so let's say S of A is called least upper bound of A if the first condition is S is an upper bound of A, okay. So this is the first condition, and second condition is if B is an upper bound of A, then B must be greater equals to S. Okay, so first I want to clear this definition, and I want it to, guys, you have to understand this definition. Okay, so it's like a least upper bound means it's like the least element of the whole set of upper bounds. So if S is an least upper bound, or in short it's called LUB, then S should be an upper bound of A, and if you take any other upper bounds of the set A, that should be at least greater or equals to S. So it should not be less than S. Okay, is this definition clear to everyone? Then only I'm gonna go with this greatest lower bound definition, because this has to be clear first, because understanding definition is very very important, otherwise you won't be able to solve questions in the assignments. Is it clear first of all to everyone? So if you have any doubts, you can ask me here right now live, otherwise you won't have the opportunity again. Any doubt, anyone? Otherwise I'll move on to the next definition. Okay, then I hope you guys have all understand this definition. So, and examples would be, so let's say A equals to close interval 0 and open 1. Okay, so this is called close 0 open 1. So now can anyone tell me what is the least upper bound of A? And this least upper bound of A is denoted by, so the LUB of A is denoted by supremum of A. Okay, so now for this set A, okay, so now for this set A equals to close 0 open 1, what is supremum of A? Now it is easier to say obviously that the answer is immediate, but if I ask you the question why, then it should be properly explained. So can you guys tell me why, what is the supremum and why is that element a supremum? Anyone?
Sir, one, sir.
Okay, 1 is a supremum, but why?
It's because any other upper bound will be greater than 1.
Any other upper one will be greater than 1. Okay, so sup of A is 1. What about maximum of A? What is the maximum of A?
It has no maximum
It has no maximum, right? Why?
because 1 is not included. It is open 1.
Okay, so it means that supremum may not attend, right? Advait?
Yes, sir.
Okay, so yeah, so it doesn't have a maximum, right? And clearly supremum is 1, because if you take any other lower bound, like say 1 point something, like say what 1 plus epsilon you can take even, so that will be always strictly greater than 1, right? So any bound on the right side is always strictly greater than 1, so that's why 1 is a supremum. And so yeah, this one is a supremum, and of course the maximum do not exist, because the maximum element of A is 1, which does not belongs to 1. So there is a proper distinction between maximum and supremum. So supremum did not exist in the set. Okay, supremum may not belong to a set, but maximum should always belong to the set, right? So now we're going to go to the next definition, which is the greatest lower bound, or GLB. So, and element, let's say T, is called GLB of A if T is lower bound of A, and another thing is T prime is a lower bound of A will imply T prime greater equals to T. Sorry, T greater equals to T prime. Okay, so is this definition clear then? The definition of greatest lower bound. So an element is called an greatest lower bound. So if it is a lower bound, okay, and if you take any other lower bound, then T should be always greater equals to that lower bound. So for example, if you take that set again, close 0, open 1, and of course another thing is that this lower bound, I mean this greatest lower bound is called infimum of A. So this GLB is denoted by infimum of A. Okay, so if you take this example again, that is A to B, close 0, open 1, then infimum of A is 0. So by the same logic as supremum was 1, that if you take any other lower bound, 0 will be always greater equals to that lower bound. So that's why infimum is 0 in this case. Okay, so is this two definition clear? First of all, to everyone, not to just one particular person. Then only I'll be going to the next question. I mean the questions from those assignments that will be helpful to solve. So is there any doubt so far? Everyone? I think there are around 10 people, right? 8 people. So is everyone getting it? Okay, so one last time, is everyone getting it? So you can reply in the chat as well, okay, if you don't want to speak. Okay, yeah, so that much better. So if you don't want to speak, you can just chat with me in the chat section, right? You can just put a message on here so that I can understand you guys are getting it, right? This is an interactive session. It's not just about solving questions, right? If I solve questions and they see I can solve 10 questions, then I can go, then it's not benefiting you, right? If you just only interact with me, then only you will be able to understand, right? Okay, so I'm gonna go with the first question. So consider A equals to 1 plus m divided by n, where m and n are natural number. Okay, then which of the following is or are true? So the first option is A is bounded below. So the short form of bounded I am writing as BDD. Okay, so this refers to bounded. A is bounded below but not bounded above. This is the first option. Second option is A is bounded above but not bounded below. Okay. Third option is A is both bounded above and below. Fourth option is A is neither bounded above or nor bounded below. Okay, so you guys can try to solve with me, and that will be, I think, the more helpful way for you. So yeah, so someone has replied A is bounded below but not bounded above. Now why is that true? Now you have to explain me, okay, if you are giving some answers. So the set A is given by 1 plus m by n, where m and n are independently varying. Okay, it's not like if m grows, n has to grow, or it has to grow in the same rate. So m and n are varying, so they are like varying natural numbers. You can take any natural numbers for m and n. Then you have to find out what is going on with the set A. Is it bounded below? Is it bounded above? Or is it neither of them? Or like it's a mixture of one of them? So yeah, one guy has replied. So Deepashri has replied. She said 1. That means bounded below but not above. Yeah, that is an correct option, but why it is true?
We can keep n as 1 and n can go on increasing.
What about n?
As n goes, we can fix n as 1 firstly. Because m and n are any natural numbers.
Yeah, that is true. Yes. So you can take any
Yeah,
fix.
so if one n
Yes. That is correct. Yeah, that is true. So so one thing you can notice from here is that 1 plus m by n is always strictly greater equals to 1. Okay, this is true for each m and n in the natural number set. So this implies that 1 is a lower bound. Okay, so in fact it is the greatest lower bound. Okay, so here 1 is a lower bound of A. Okay, but if you see the set closely, then you can understand that this set A is not bounded above, right? Because if you fix n, so let's say, so let n be fixed. Okay, so say n equals to 1. So then the set A looks like this. Okay, so now if you increase m, then it doesn't have a lower bound, upper bound. So A is clearly the elements of A clearly going to infinity as m approaches to higher and higher values, right? So A is not bounded above, correct? Is there any doubt? Okay, so I assume everyone has got it. So it will be the first option, right? Is it clear to everyone? Otherwise, I'll go to the next question. Okay. So the next question is consider a equals to this is square root of n minus where n is in n, then which of the following is less r true? Okay, so the first option is a is not bounded above. Second option is a is not bounded below. Third option is a is a bounded set. Fourth option is a is not a bounded set. Okay, and this is actually a greatest integer function. Okay, so do you guys know what is a greatest integer function? This is the first question. So this is a very important question. Actually, if you are preparing for IIT JAM exam or GATE exam, then this can be helpful, or especially NET exam, because this type of question has been asked in the NET exam. Okay. Anyone know the answer? So the set A is given by square root of n minus this box function, or the greatest integer function square root of n, where n is a natural number. Then you have to tell me that if A is bounded above, below, or bounded, or none of them. Anyone? So you can write in the chat if you know anything. So it can be wrong, that's okay. So you need not be correct always. If you have any like questions, suggestions, or doubts, you can put in the chat.
So it is bounded both above and below.
Now, why is that true?
Because so the greatest integer no, that is so the difference is always between 0 and 1, because it's the fractional portion. That the root of n minus floor of root of n gives you the fraction.
Yeah, I understand, but why is that always between 0 and 1? You are giving me the definition just right. I mean, so I understand this is a known function called fractional part function, I know. So its range is always between 0 and 1, but why is that true?
Yeah, so maybe I can say this way. It cannot the greatest integer fraction cannot be greater than square root of n. So this result will always be a positive integer. 0 is either 0 or positive. So that way, so it has a lower bound of 0.
Yes. And then what about 1? That's true.
I can see it, but I'm number, then it becomes sorry, I can't pick an example where it will be equal to 1. Can't be greater than 1 because that is the definition of the calculation, right?
And also it can never be 1, right?
It can never be 1. Right?
Yeah, but why it can never be 1? Okay, so maybe I'll explain all of this. And I think before solving this question, maybe I'll explain what is the greatest integer function, what are the properties, and what the graphs look like, right? And then it will be better to solve this question, right? So, do anyone know anything about greatest integer function? What is like how can you bound a greatest integer function? So if you can like bound the greatest integer function between two values, then you can do something with that, right? Then maybe you can doing something like minus and plus, you can get an upper bound or a lower bound. Okay, so first I think I'll start with this function, the floor function, the greatest integer function. So this is actually defined in the set of natural numbers. Even if you put any real number instead of n, like instead of square root of n, this is always true. I mean, like answer will be same. So here just putting natural number does not change anything. Okay, so if I just replace the square root of n by just any natural number x, then the answer will be same. So the greatest integer function is defined like this. So I prefer writing box of x, but sometimes this is also defined like this, that you take the L and then another you take a mirror image of L. Okay, both are perfectly fine. So greatest integer function means actually so if you take a real number, let's say, so this is the real number system, right? This is 0, this is -1, this is 1, and this is 2. So if you take any number between two integer, the greatest integer function will be always the left side integer. Okay, so here if you take any number between 0 and 1, I mean which exclude 1, so the greatest integer function of that number will be always 0. Okay, so it is written like this. So if you take for example 0.5, then this box function of 0.5 will be 0. Okay, similarly if you take, let's say, 1.7, the box function of 1.7 will be just 1. So the leftmost integer will be represented as a box function of that number in that interval. Okay, so now again if you take for example minus of 1.5, can anyone tell me what will be the box function of minus of 1.5? Minus 2, right? So this will be minus of 2. So that means this box function is defined like this. So it is 0 if it is less equals to if it is 0 less equals to x less than 1, 1 if 1 less equals to x less than 2. Similarly minus 1 if minus 1 less equals to x less equals to less than 0. Okay, similarly 2 if 2 less equals to x less than 3. Okay, now it will go up and down again. So it can be going for -2, -3, so on, and similarly for 2, 3, and so on. Okay, is it clear how the box function is evaluated? So it's like a function from R to R, or you can say R to Z. That's why it's called the greatest integer function, right? So do anyone know what is the graph of this function? This is the famous graph. Some like is it looks like an
So it is a step function.
yes. It will be a step function, right? So it will look like a staircase. So I'm gonna draw this graph right now. So let's say this is 0, this is 1, 2, 3. So this is -1, this is -2. So now you see between 0 and 1 it is always 0, correct? So this will be the point somewhere here. And if you take between 1 and 2, it is always gonna be 1, correct? So yeah, so this is gonna be somewhere here, okay, and then again here, and then again somewhere here, okay. So this is like a step, right? Is it clear? Okay, so this will be the box function, the graph of the box function, okay. So now let's come to the question. So the function was defined like this: x minus box of x, correct? So now you notice one thing, that box function is always less equals to x. This you have to see fast, because box function is always the leftmost integer, and since we are on the real number system, the right side integer will be always less equals to, or the right side real number will be always greater equals to the left side number. So since this box function lies on the left side of that x, x will be always greater equals to that box of x, correct? Because we are taking box x to be the leftmost integer, and x can be anything on the right side, right? So that's why x is always greater equals to box s, and this is always less equals to box x plus 1. Because if you, for example, if you take a number here, let's say this is x, then box x will be 0, and if you add 1, then it will be box x plus 1 equals to 1. So that is it gonna jump to the right side by one step integer, right? So if you take a number from, for example, here x, so let's say 1.5, then the box function of 1.5 will be 1, and if you add another 1, it will be 2. So 2 is always greater equals to that 1.5. So that means for any real number x, box function will always lie between, x will always lie between box x and box x plus 1, because that's how we have defined the function, correct? This is just graphical, this is not any theoretical things here, because from the graph we can see that x is always greater equals to box x and less equals to box x plus 1, correct? Not less equals to, you can say it is strictly less than box x plus 1, because it can never be box x plus 1. What doesn't matter whatever integer you take or whatever number you take, right? This will be strictly greater than x, because for example, if you take a number which is closer to 2, let's say 1.999 something like that, then the box x will be 1, and if you take another 1, it will be 2, and 2 will be always greater than 1.99, because that's what we have learned in the decimal representation, right? 1 is always greater than 0.99, correct? So although we can say 0.999 is 1, but 1 is strictly greater than 0.999. Okay, so if you have used Python, then you might have known, or you might have seen that 0.1 plus 0.2 will never give you 0.3 in computer system. Okay, it will always give you 0. something 30045 something like that. So because computer does not know the approximation, something like that 0.9 is approximated to 1. So I hope you guys have understood how this x is lying between box x and box x plus 1, and if you have understood that, then I think it is clear that answer is close 0 open 1, right? So that means 0 less equals to x minus box x less than 1. So that means, and this is true for each x in R. Okay, so in particular, if you take x to be square root of n, then 0 less equals to square root of n minus box function square root of n less than 1. Okay, so that means our a is close 0 open 1. Okay, so a is a bounded set, right? The supremum is 1 and the infimum is 0. Is it clear for everyone? Now I'll give some exercises, I think, which is not part of this assignment, but I'll give some ideas to work. I mean, you guys can try to work on your free time, and it will be much more interesting to solving this type of questions. So actually you can try to find out derivatives of box function. Okay, integration of box function. Now one thing you can see from here, the definition of the box function, that at the integer point the function is not differentiable, right? This is like not for the assignment, okay, this is for general understanding. So clearly you can see that the box function is not continuous at the integer point and also not differentiable at the integer point, because if a function is not continuous, it cannot be differentiable. So if you are also preparing for PhD interviews later in your life, then the interviewers can ask you this type of questions, that give me an example of a function which is not differentiable in the whole set of integers, or not continuous on the whole set of integers. Okay, so this is a good question. And another thing is although the function is not differentiable, but the function is actually integrable. Okay, there is a big theorem regarding this function, so which we will learn probably in this real analysis course, when the TA will be, I mean the guide will be teaching the integration part. Then you can see that a function is differentiable if and only if set of discontinuity has measure 0. So here the set of discontinuity is actually the set of integers, because you can see from here that the function is not continuous on the set of integers, and set of integers has measure 0. So from there you can prove that box function is integrable. Okay, so two tasks I am giving: try to find the derivatives in between the intervals. So try to find the derivative in the interior of those domain, like say 0 and 1 or 1 and 2, and try to do it for each interval, and similarly try to do the integration for box x. Okay, so yeah, so I hope this question is clear to everyone. Otherwise I will explain it again. So from one question we can see that we can derive a lot of questions. So not only that, even in the competitive exam, what I have seen is that the people who set up the questions, they will ask questions definitely from this box function or the low integer function or the square root of function. So something they will combine and then make up a question that will be very, very interesting. Okay, so you can try to solve this type of questions whenever you get the chance. So now I think I'm gonna go to the next question. So I hope this is clear for everyone. So the next question is, let A be a non-empty subset of R. Let k greater than 0 and define k equals to sorry, this will be a, then which of the following is or are true? Okay, so the first option is supremum of k is k sup of a, infimum of ka is k sup of a, infimum of ka does not exist, and then supremum of k does not exist. So the short form for does not exist is DNE. Okay. Yeah. Is this question clear to everyone? So you guys can do it with me, so then it will be a practice for you as well. Any answer on the chat if you don't want to speak? Okay, so yeah, so someone is saying, Dipashri is saying it is 1. Yeah, it is 1, but why? Any idea?
Yeah, A is any set, it is non-empty, and K is positive.
Okay.
So that set is just a multiple of positive number.
Okay, then?
So whatever is the supremum of K, it is going to be multiple of K. If you take the supremum of A.
Yeah, I understand that, but that is not a mathematical justification, right?
So A is an ordered set of real numbers.
Yeah, okay. Obviously, R is an ordered set. R is an ordered field, not only a set.
So if K is a positive number, multiplying it to the set won't change the order.
That's okay. But what about the supremum? I mean, why the supremum is like, why the K is getting outside? Only just because of positivity, or? So do ordered field play a role here? I don't think so, right? Anyone? So can you just use the definition whatever I have used in the beginning? Yeah, the intuition is correct that if k is a positive number, then if you apply, like if you multiply those numbers to a set, so let me tell you that k of a is actually called the Minkowski set. Okay, so these are called Minkowski set operation. So if you add to set a plus b or multiply a number with a set, so these are all called Minkowski set application. I mean Minkowski set, or multiplication of Minkowski set, or additivity of Minkowski set, and so on. So the idea is correct, obviously, that if you multiply a set by a positive number, then if you take the supremum, then that will be same as the supremum of a multiplied by that real number, I mean that positive real number. So the positivity does not change it, but you have to prove it, right? So saying something does not work until you show it, especially in mathematics, right? So I think we all can start by the definition of supremum of A. So do you guys know the definition or the epsilon definition of supremum of A? Can anyone tell me the epsilon definition of supremum of A? Because that is what gonna be used most of the time. I think I have not written it in the beginning. I just give the definition in terms of the upper bound, but there is an epsilon definition of supremum of a set A, and that is the most useful definition. So the idea is, if you take another element that you claim to be a supremum, then you can get an element between those two elements such that that number will be greater than your claiming element. So what I mean by that is, I'll explain here. So let's say this is a set. Okay, so okay, so this is a set A, and let's say this is U, and U is the supremum of A. Okay, so now if you say that this is a supremum, let's say V, then what gonna happen is, between U and V, you will be getting a number which will be strictly greater than V. Okay, so let's say this V is U minus epsilon. So you are going just a little bit, just epsilon to the left. Then you can find a number between this U minus epsilon and U that will be greater than U minus epsilon. So that means U is supremum of A if given epsilon greater than 0, there exists an Y in A such that Y greater than U minus epsilon. Okay, is this definition clear? Is this like understandable? The geometry is clear? Why it is called supremum? So if somehow you decrease the element by epsilon, it will form an interval, and between that interval you will get an element that will be strictly greater than U minus epsilon. Okay, and this is the most usable definition that you have to remember at least, or you have to understand, that you will be applying throughout your life if you are in mathematics. Okay, so this is the definition of supremum of A. Now let us try to use this definition to prove that supremum of K is actually K times supremum of A. So let S equals to supremum of A. Okay, then by the definition of supremum of A, x will be less equals to S for each x in A. Okay, is this clear? This is just the definition of supremum of A, right? So now, since K is positive, so now you are using this fact here. This is just halfway the proof, another halfway is there also. So since K is greater than 0, Kx will be less equals to Ks for all x in A. Okay, now what this tells you? Anyone? What this definition tells you?
Ks is the upper bound.
Ks is an upper bound of what?
Set Ka.
Correct. So this implies that Ks is an upper bound of k. Okay, so what remains to prove now? Anyone? So it can be wrong, you can tell me, okay, then only you will understand. Okay,
It is the least upper bound.
correct. The only thing left to finish this proof, to complete this proof, is to show that k is the least upper bound of k. Correct. So by contradiction, let's say k is not an upper bound of k. Okay, I mean the least, not the least upper bound. So if k is not an least upper bound, then there exists an epsilon greater than 0, for given epsilon greater than 0, so there exists an y from k such that y is greater than ks minus epsilon. Okay, this was the definition, right? The definition of an least upper bound, that if that number is not a supremum, then you can take less than, I mean ks minus epsilon, like epsilon to the left of that number ks, then you'll find a number between ks and ks minus epsilon that will be greater than ks minus epsilon. Correct. Is that clear to everyone? So now you see that y is in k, right? So this will imply y equals to ky prime for some y prime in a, right? So then from 1 we have ky prime greater than ks minus epsilon. Is it clear up to this step? Everyone? Is it clear up to this step? Because
Yes,
yeah, okay, a lot of is going on. Okay, so I hope other is also getting, except this 2 or 3 people. Okay, so now since k is positive, you can multiply, you can divide by k both sides, and that will not affect, right? That will not change anything about the inequality, right? So it will be strictly greater than s minus epsilon by k. Correct?
yeah, yes.
So now can you tell me what is going on here? What, like in what situation we have arrived right now? Anyone? So there is another one line to finish the proof.
So we got some element y dash in A, which is the upper bound of the set A. There is a contradiction.
No, y prime is not the upper bound, right?
No, it is not the upper bound. That's gone.
So we have got some element such that s minus epsilon k, I mean s is not an like least upper bound of the set A. Correct. So this is implying that, so this is a contradiction, let me say. This is a contradiction to the fact that S is supremum of A. Correct. So if this is a contradiction, then whatever we have assumed in the beginning should not hold. Correct. So that means this implies that Ks is the least upper bound of Ka. Okay, so Ks should be supremum of Ka, which is K times supremum of A. So I hope this is clear, because we have gone through a lot of things. And so when I was a bachelor student, I could not understand how these things are happening. But when I went through the proof myself, then it was crystal clear to me. Okay, so so you can go through this proof again by yourself and try to write on the copy, and then only you'll be able to grasp it. Okay, so I hope this is clear to everyone. And so for this question, option 1 should be correct. And I encourage to find out and counter example for option 2. So you don't have to do it right now, you can do it later, but try to find an counter example that why this 2 is not happening. Okay, and obviously 3 and 4 are not correct, because if a set is bounded, if and only if so I think it is not given bounded, right? Let me see the question, just wait. Yeah, so one correction in the question, it was bounded also. Okay, because if it is not at least bounded above, that we cannot talk about supremum, because that is one of the principle we have to assume, that the set is bounded above, right? So in the question it was given it is a bounded set, so that means both supremum and infimum exist. Okay, so please write it is a non-empty bounded set, not just non-empty set, because if it is not at least bounded above, we cannot talk about the supremum. So I hope you guys have understood this question. Then we're gonna move on to the next question. Okay, so let us write the next question. For n in n, let fn equals to x in r such that minus 1 by n less than x less than n. Okay, then the collection n forms an open cover of minus 2 comma infinity, forms an open cover of minus 3 comma infinity, forms an open cover of close 0 open infinity, and the next option is none of the following above. Okay, so please write out the question first and try to think for a minute or two, and then tell me what you think, like what is your conclusion. So another thing is that to solve this question, you have to know what is an open cover. So I hope everyone knows what is open cover. and before that you have to know what is a cover. So if you have studied metric space, then you might have seen this, and I suggest that Principle of Mathematical Analysis book by Rurin. That is one of the finest book you can have to understand metric space. Okay, I personally recommend this book to everyone. So yeah, anyone?
If we take any element of the set, whatever is the set, it should belong to one of the cover, one of the set, F1, F2 or F, any of the set from that. So maybe the third option is correct, 0 to infinity. Because if we go for F1, it covers the part from -1 to 1.
Okay.
So 0 to 1 is covered by the first set F1.
Yeah,
We go for F2.
yeah, that is your intuition, right? Like you are just understanding by seeing elements one by one, right?
Yeah.
So do you know the definition of an open cover?
Yeah, if we take a set, collection of set Fn will be open. It will be a open cover of the set A. If for every element from that A, it should belong to one of the set.
Yeah, that's true. So that means not only belong. There should be another thing, right? That each set should be open.
Yeah. Yeah.
Okay. So a set, for example, a collection of set is called cover of a set A subset of X. So here X comma D is a metric space. If A is subset of union of alpha belongs to I, if alpha, okay, then only this collection is called a cover. Now if this collection is if this if alpha is open for each alpha in I, then this collection is called an open cover, right? So if alpha is open for all alpha in I, then this collection is called an open cover. So I think it is a good thing for you that you at least have the intuition to understand why, or maybe like why it can happen. But if you are not able to prove, that is also okay, because intuition is the first thing you need to do a proof. If you don't have the intuition, you cannot do the proof, right? So I think this is a positive thing for you. Okay, so also there are many definitions regarding cover, because covers are like the definitions of cover is given only mainly for the compact sets. I don't know if you guys know the definition of a compact set, but open cover is an important part of compact set, that a set is compact if and only if every open cover has a finite subcover. Okay, so that's why the definition of cover was found. And also there is a concept called totally boundedness, and there also you can use this definition of cover. Okay, so we'll be coming to that definition later. So let's come to the question. So here this collection is given, Fn equals to I'm sorry, yeah, Fn equals to -1 by n comma n, right? So clearly this set is open for each n in the natural number set. So one intuition we can see that as n grows, -1 will converge to 0, correct? And n will be going to infinity, right? So the set will be like the, for example, if you put n equals to 1, it will be -1 comma 1. If you put 2, it will be -1 by 2 comma 2. and as n grows it will be approaching to 0 on the left side and infinite on the right side. Correct? So our intuition is this closed 0 open infinity should be subset of n equals to 1 to infinity f of n. So this is our first intuition. Okay, now we have to prove it, otherwise it does not make sense, right? So let's say x is in closed interval 0 comma infinity. So to prove this subset, that A is subset of B, so for example, if there is two set A and B, and if you want to prove A subset of B, you have to show that each element of A belongs to elements of B. I mean, like every element of A is also an element of B, and if you can prove that, then you are done, right? So let x belongs to closed interval 0 comma infinity. Then we have to show that x is in Fn for some n in the set of natural numbers. So now if you can prove that x is at least in one of this Fn, then you can say it is in the union, right? Because for union you don't have to show that it belongs to each set. If you can prove that it belongs to the one set, that means it belongs to the whole union. And for intersection, you have to prove that each belongs to the every set on that intersection. Correct? So now you see that x is positive, then you can choose a natural number such that n greater than x. Now I want to give a pause here, and can anyone tell me why I'm pausing here? Because I'm pausing here, I want to ask why there always exists a natural number such that n is greater than x where x is positive. How do you guarantee this? So here x is positive number, positive real number. What?
It's Archimedean property.
Yes, it is an Archimedean property. How do you apply that?
By contradiction.
Okay. What is the contradiction?
Suppose all the natural numbers are less than x.
Okay.
Suppose there is so then it is natural numbers become bounded above.
Yes. That is
This is
true.
a contradiction.
True. Yes. So that's why it's called the Archimedean principle. So it says that given any x and y greater than 0, where x is positive and y is any real number, you will be able to find a natural number such that nx greater than y. And if it does not happen, then n will be less equals to x by y. That means the set of natural numbers will be bounded above, which is a contradiction, right? That is not true. So here, because of Archimedean principle, because of the Archimedean property, there exists an natural number which will be strictly greater than x, no matter how large x is. Okay. So now from here, see that minus of x is greater or equals to minus of n. Yeah, sorry, my handwriting is not that good actually, but the left side is x and right side is n. Okay, for this minus x greater or equals to minus of n. So this is implying that minus of 1 by x is less equals to minus of 1 by n. Is it correct? this is not correct, right? So x is less than n, then minus of 1 by n less than x. I'm sorry.
X is already greater than or equal to 0, so it is greater than minus 1 by n.
Yes. This will be strictly greater than minus 1 by n. So this is implying that x belongs to f of n. Okay. So we got close 0 open infinity subset of union of n equals to 1 to infinity f of n. Is it clear to everyone how we get it? So now I think if you have got it, then I have another question. Can you guys tell me what is this actual union? I mean, if you take the union n equals to 1 to infinity f of n, then what set are you getting? So one thing we have understood that closed 0 infinity is subset of this union. So whatever set you get by taking this union, it should at least contain 0 infinity, right? So can anyone tell me what is this union actually? So this is
minus 1 infinity.
Why is that true?
The for f1 is minus 1 to 1.
Okay.
The next f2 is minus half to 2. So that minus 1 by converges to 0.
Okay.
So and the smallest element is minus 1 if it's all the sets.
But how it comes to the whole union that minus 1 comma infinity? Can you prove it? I mean, can you give me an idea on how to prove it? Okay, so maybe you guys can try to find out. So she is actually correct. It should be okay. So you can prove that this union is actually minus 1 comma infinity. Okay, so this is an exercise for everyone. So please try on your free time. Okay, so is this clear to everyone? Otherwise I'll move on to the next question. So what about other people? I mean, only 2 and 3s are replying. So is everyone getting it actually? Otherwise there is no point of doing this class if you don't understand it, right? I mean, if you are not getting it, you can ask me questions right now. This is like one opportunity for each class. You will not be able to ask many questions, right, in the next class, because in the next class also I have to solve other questions. If you have any fundamental doubts, it can be small, it doesn't matter, you can ask me, right? Because for the recorded lectures you don't have the opportunity to ask questions, right?
Sir, I wanted to ask, if we want to practice some more questions, then can you tell us a website or a book that we can get to practice some?
Yeah, I think in the last class I referred some book, right? Maybe you can see that video. I referred 3 books. For fundamental understanding, you can go to that fast course in real analysis. That is also a good book by let me check the name. I think I have the books, but I cannot show you here right now. uh, is called Protar and More, and there is another book, Starling Barbarian. And for understanding about metric space, personally I recommend that book, by Walter Rulin, I mean the Principle of Mathematical Analysis. And there is another book which I really like, is that SK Mappa book. I don't know if you guys know that, so maybe I can write it here. Especially for set theory, sequence series, limit continuity, differentiation, integration, sequence of functions, series of function, and calculus of variation. So this is the book what I have studied from my masters, from my bachelor's and masters. And if you master this book, no, like you will be getting everything in real analysis, in mathematical analysis, in even complex analysis. This is not a complex analysis book, but you need an understanding of real analysis to understand complex analysis, right? So I personally recommend this book. You go to this book, you solve each and every exercise from set theory, from continuity, differentiability, limit, and integration. Then you'll grasp everything. Okay. So I hope this is clear. And this book is, I think, online available. You can go to some. I'm not saying those websites, and probably you might know. So yeah, you can easily find out. You don't need to buy right now. I mean, because books are available online everywhere, right? So yeah.
Thank you, sir.
Okay. So yeah, I'll go to the next question now. So it will be question number, I forgot, 5. What is the question? So this is a simple question, but I think it is needed for other people who are not getting, or not, who don't have the concept of closed set and open set. So this set Q intersection closed in open interval 0 1 is closed, is open, nota. Okay. So yeah, anyone? Any idea, anyone? Which option is correct?
Third option,
Why?
you can use the irrationals. Let's say, no. So,
Yeah, you can discard the options one by one, right?
it's not open because if we say it is open, then every neighborhood should be totally contained in the set. If you take any element in the set, it should be able to find some epsilon such that the interval, the neighborhood should fall entirely in the set, which is not true because of irrationals numbers.
Okay, so
0 1.
yeah, so then I want to ask you one question. So it's not from this question. So then why this given an intervals you are getting an irrational number? Do you understand my question? So you said that if you take any
I think
point.
it's that Bolzano-Weierstrass theorem. I don't remember it actually.
Okay, I see.
Only two irrational, there is an irrational number.
No, this is not Bolzano theorem, right? Bolzano theorem is different, right? It says that uh, Bolzano theorem was not about this set of real numbers or rational numbers, right?
Sir, would there be infinite rational numbers between any two rational numbers?
Sorry, tell me, I didn't hear you.
So won't there be infinite rational numbers for every epsilon greater than 0? Like infinite rational numbers between any two rationals.
Yeah, but why is that true? That is the question I asked to her also, right? Why given any two numbers, there are infinitely many irrational numbers as well as rational numbers?
So if you take two rational numbers and try to compute the arithmetic mean, and it will always lie between the two rationals.
Okay, but what about others numbers? So you just found another only one irrational number. So you ask the question, right, that between any two real numbers there is a rational numbers. There any two rational number there is an irrational number. So this is a fundamental property of denseness, right? Have you guys know this fact that Q and Q complements are dense in R? This is the main result, right? Rational numbers are dense in R, right?
Yes, yeah.
And why is it dense? Okay, this question you guys ask yourself, why Q is dense. Don't just assume Q is dense. You have not seen that Q is dense, right? Or you have not understand Q is dense. Then why you believe it, right? So try to see some. So you try like take some standard books. Maybe you can take this Schemapa book, or you take the fast course of real analysis by those two guys. Then try to see and do the proof by yourself that why Q is dense, why Q complement is dense, and what is the definition of dense set. Can you guys tell me? What is the definition of a dense set? Because that I will be coming later in this course about denseness, compactness, connectedness. This all will be coming when you'll be solving questions for like probably week 3 or 4. I'm not sure. But so a set is called dense if it contains, so if its closure is whole of R. So that means if you take any non-empty open set and take intersection with that set, so the intersection should be non-empty, right? So dense means what? In general, dense means lot of elements are there. You cannot separate 2 points. That is what the definition of dense, right? You cannot separate 2 rational. If you take 2 rational, there will be rational plus irrational. So that means it is like compactly, like the elements are compactly there. I mean, you cannot separate elements in such a way that there will be always rational, there will be always irrational, right? So there are a lot of definition of dense set. One definition is this set D subset of R is dense if D closure is R. If you take an open ball in R, if you take the intersection with D, it will be non-empty. The sequential definition is if you take a sequence from R, if you take an element from R, then you can find a sequence in D that will be converging to R. Okay, and these all are equivalent. So I encourage everyone to go through the denseness of Q and R. So I'm gonna write in here. So you see here, Q is dense, Q and Q complement is dense in R. Okay, and definition of dense, definition of dense set. Okay, and why let's say 1 by n such that n belongs to n is not dense in open zero. So these questions you can try to find answers when you have some free time. Okay, so this is just exercise, this is not part of the assignment, because the goal is not just to solve assignments, the goal is to have an understanding of the topic, right? So let's come to the question. So the set is given like this, that you take all the rational number in open interval 0 1. Okay, and we all know that set of rational is countable, that also remember. Okay, so first of all, this set is not closed, because if a set is closed, it should contain all its limit point, right? Correct, this is the definition, right? A set A is closed will imply A prime contains A, and this is an if and only if contains. So this A prime is the set of all limit points of A. Okay, so I am removing this one. So now can anyone tell me why this set is not closed? Q intersection 0 1. Now we have gotten clue, right? Because the set is not closed. So if you take, let's say, A in Q intersection 0 1, then there exists a rational sequence Rn or I'm sorry, so this is a collection of limit points. So can anyone tell me why the set is not closed? So what you can do is you can take an irrational number A from Q intersection 0 1, then you can find a natural number, I mean a rational sequence An in Q intersection 0 1 such that An converges to A. Okay, and this is coming from the dense property, because I just have explained, right? Okay guys, so I think this is also similar to the question of the first one. So you have to also use box function to try to change into a rational sequence. Okay, so probably I'll answer this 1 and 3 in the next class. I have forgot the sequence, but if it is a rational sequence, then it is easy. You can take just A plus 1 by n or A minus 1 by n. Okay, so I think I have given a lot of information for this one question. So let's come to the question. So A is not closed, and of course A is not open. If a set is open, then if you take any open ball, then that should be a subset of that Q intersection 0 1, right? But if you take an open ball, it will contain also irrational numbers, right? So let us call it let's say E, and this is not open because for any r greater than 0, px comma r intersection q complement intersection 0 1, this is non-empty. Okay, for any r greater than 0 and x in E. Okay, so it means that if you take any rational number or any elements from E then for any ball you will always have a irrational number from open 0 1. Okay, so that's why the intersection is becoming non-empty. Okay, so that means that b of x comma r will not be subset of E, so E is not open. And this is also coming by the definition of denseness. Okay, so I am encouraging to everyone to go through the definition of denseness, especially the sequential definition, the definition in terms of the open sets, and also that closure definition, that if D is dense, then D closure will be always the whole space, even in it is true in metric space. Okay, so E is not open. So is it clear for everyone, or should I explain again? So you can tell me a specific part where I have to explain right now, or then I can explain. Any doubt? Anyone? It is clear, right? So you guys can go through this Q intersection equals to R, why it is happening, why the Q complement closure is R, why Q intersection 0 1 closure is open 0 1. Okay. Similarly, why Q complement intersection open 0 1 closure is also open 0 1. Because of this denseness property it will come. Okay. So then I'll go to the next question. This is also a very important question, and this is question number 6, I hope. So the set x in R such that sin x is non-zero is closed, open, compact, and contains only rational numbers. None of the following above. Okay, so you guys can take 1 or 2 minutes to try this question, and then I'll solve this one. This is a very, very good question. Okay, because it uses a special property, and yeah, you can use that property from. So this is like from continuity. So if you have understood continuity in terms of open set or closed set, then it will take like less than 10 seconds for you. Anyone? Any guess? Comments, suggestions? Anyone? So there are two approaches to solve this question. and I think I'm gonna show both of them. Shall I move on to solving, or do you guys have any guess? Anything? Can you guys just guess? It can be wrong, that's okay. And if you are thinking it is like if, for example, if you say that it is closed, then you can just tell me why you think it is closed. Then only I'll have an understanding like what you are thinking, right? So one thing you can do is that try to find out in which points the sin x is 0, right? So let's say this set is E. So then this is clearly a subset of R, right? So which point sin x is 0? Anyone?
So n pi.
N pi, right? So and what is n here?
Natural numbers.
Only natural numbers?
Sorry, integers.
Integers, right? Because the graph of sin x looks like this. Correct? So this is our x-axis, this is our y-axis, and it goes on like this. Okay, and this point is 0, this is pi, this is 2 pi, and this is 3 pi. Similarly, this is minus pi, and this is minus of 2 pi. So the set sin x is 0 is just this one. So x is in n pi such that n is integer. Correct? Is it clear up to this stage? If it is clear, then you're gonna get the answer immediately. So you can see we have taken those points such that sin x is 0. But we need sin x to be non-zero, right? So that means what is the set E actually? Anyone? What is E actually?
R minus n pi.
Yeah, that is correct. So R minus n pi, right? Correct. So can you explicitly write this set? Advait, can you write this set explicitly?
So what does explicitly means?
I mean, I want to see as like more explicitly means here. I want to see as a union of some set, because we don't know what is going on here, right? Because R minus n pi doesn't mean much, doesn't give you more information, right? So this set will be, what is R? R is union of open intervals, right? So I mean, you can write it like this. Is it clear now? Can you write like this? Yes, right?
Yes, sir.
Okay. So this is same as n pi comma minus n pi comma n pi, n is in z. Now does it make sense? I mean, it will be n plus 1 pi, sorry. I'm really sorry. So this will be minus of n pi and n plus 1 of pi. Correct? Is it clear? Or more explicitly, you can just remove this minus. Yeah, this is more convenient because n is already an integer. It can take negative values. Why to write negative values on the union, right? So you just like put n equals to 0, n equals to 1, n equals to -1, and you're gonna get this whole of r minus n pi, right? Now this is an union of open sets, correct? Each set is open, so that means the whole set is gonna be open, correct? Because n pi comma n plus 1 pi is open for each n, right? And any collections of union of open set is always open, right? Do you guys know this result? I think it has been proved in the week 2 lectures that if f alpha is a collection of open set, then the union is always an open, but intersection need not be always. Okay, so this implying that E is open. Okay, so there are many ways to prove this. Another way was to show that this set is closed, that n pi comma n belongs to z. If that set is closed, the complement should be open, right? And we already know that z is closed. If z is closed, you multiply by pi, that will be also closed, and this set is just pi of z, correct? Correct. So E is just r minus pi of z, and pi of z is closed. It's a closed set, correct? And complement of a closed set is open. Complement of an open set is closed, correct? So pi z complement equals to E is an open set. Okay, is it clear to everyone?
Yes, sir.
Okay, so there are also other approaches, which is the beautiful one. I like the third approach because the first two approach are much more explicit. That means you have to elaborate a lot to prove that a set is closed or open. But there are also very nicer way. Okay, the nicer way is using continuity. So there is a theorem. So it says that, so let x comma d is a matrix space, and f from x to r is a continuous function. Okay, then inverse image of open or closed set is open or closed. Okay, so it means that if you take inverse image of open set, it will be open, or if you take inverse image of closed sets, it will be also closed. So this is sets. Okay, so now if you just apply this theorem, it is just 10 seconds. It will just take 10 seconds to prove that the set is open, correct? So what you're gonna do is you have to just find out what is x and what is f, then you are done. And also you can define the right side as well. So for that set E, you see that you can take fx equals to sin x. Okay, and define this function f from R to R. Okay, sin x is a function from R to R, right? So then f inverse of R minus 0 is E. So how many of you can see this thing, that f inverse of R minus 0 is our E? Okay, I assume everyone has understood. So now you know that R minus 0 is open, correct? Because singleton sets in R are closed. So the complement, which is R minus 0, should be open. And by the above theorem, inverse image of an open set should be open. Correct? So by theorem 1, E is an open set. Okay, it's so easy, right? You don't have to do a lot of things. You have to just find out the function and the set, I mean the open set, which you gonna take the inverse under that function. So here is the inverse is not the function inverse, is the set inverse. Okay, the pre-image of R minus 0 is not the inverse of sine function, because the inverse does not exist for sine function in this domain, right? Then you have to restrict the domain, then only the inverse exists. So I hope everyone has got this result. So keep this result like 3 star or 5 star, because you're gonna use this in many times. So a lot of questions from competitive exam can be solved using this theorem. Okay, so I'm just want to ask another question. Is it true for complex sets? Do anyone know? So if the function is continuous, then is it true that inverse image of compact sets is also compact? Do anyone know? This is also an important result, because in TI4 exam this has been asked, I think few times, quite a few times, as much I remember. Okay, so I'll be writing as a fact here that inverse image of compact set need not be compact. Okay, okay, but if you take the image under continuity, then the image will be compact. So that means compactness is preserved by the continuity, but not by the inverse of the function. Okay, so the another fact is, if f is continuous and k subset of x is compact, so CPT shortly stands for compact set. Okay, then f of k is also compact, and here f can be any function. So it need not be from x to r, it can be between any two metric space x comma d and y comma d prime. Okay, so from the fact 1 you can see one thing, that inverse image of closed set is closed, right? But inverse image of compact set is not becoming compact, correct? But why is it like lagging? I mean, which property is lagging here? Do you guys know what is going on here? So it's actually that inverse image of bounded function, I mean bounded set, need not be bounded. So that's why by Henry-Borel theorem, inverse image of compact set need not be compact, because compact means closed and bounded, right? The inverse image of closed set is becoming closed, but the compact set need not be becoming compact, right? The counter example is you take this function, any constant function, then the inverse image of any compact set is the whole of R, right? Which is not a compact set. Okay, I hope this is clear. You guys all can go through it once again. So let me come to the question. So it is open, right? Not closed or compact or contains only rational numbers, right? Is it clear to everyone? So yeah, if you have any doubts, you can ask me right now or maybe in the next class. So I think you have to go through all of this again to understand, I mean especially the last parts, right? So yeah, I mean whatever notes I have given as a theorem or fact are very very important, from the point that using it you can solve a lot of questions later. Okay, so yeah, and if you want like more graphs on the topics, then you can try to solve some competitive exams questions. I encourage to do this because it will help you understand your concept more clearly. Okay, so see you guys in the next class, and which will be probably on 9th of August, I believe. Yeah, 9th of August. Yeah, next class will be 9th of August, right? Or next Sunday is 9th of August, right? Yes. Okay. So any doubt, or we'll be wrapping up? Anyone? Okay, then this is all for today. Okay guys, good night, bye everyone.